Okay, we're going to look at a different way of looking at algebra. Um, I got this from a Canadian textbook, Algebra Tiles, and then I investigated a little bit more. There's a Hungarian mathematician and math educator from a long time ago that came up with this method, and it's been developed, and I don't know, I just think it's kind of an interesting way, and it might help some people to understand algebra better. So this is, and I think it's kind of interesting. We kind of play sort of a game with it to solve algebra problems. Now, anyways, here we go. We're going to actually have sets of these algebra tiles. I used old pens to do it, but the way I set up the sets is we've got 7 parts each here. Each one of the long bars stands for x. The blue ones are positive x's, and the black long bars are equal to negative x's. And the smaller ones there, they stand for just units. So we've got 1, 2, 3, 4, 5, 6, 7 units here. So that's what we're starting up. We're kind of playing with that. Now, if I told you to build an equation, you'd make an equal sign. And if your equation was 4x plus 2 equals 2x plus 6, then you'd have this. Now, everything's positive here, so the first example, we're just going to start with blue ones. So we'd have 4 blue x's, 2 1s. It equals the 2 x's here. The long bars stand for x, and then 6 of these small ones. Okay. Well, what could we do with this? Well, we could not even think about black ones and just do a thing like this. What if we had these bars here like that? If I took away these 2 on this side, and then I did the same thing on this side of the equation and took away these 2 units, then we'd be left with 4x's equals 2x's plus 4. Now, the thing with x, they're like a bag or a box. You don't know how much is in them, but the same amount is in each one. That's how the x thing works. It's an unknown. It's a variable. Well, look, what have I done to get from here to here? Well, there's 2 less. Well, I took away 2 here, and I took away 2. I took away 2 x's from both sides. Now, I've got 2 x's equals 4. Well, if I arrange these a little bit differently, let's put the x's on their sides. And then I split these 4 into 2 groups. I'm looking at my answer for what x equals. X equals 2. Now, we learned this thing when you've got 2x equals 4. What do? You divide both sides by 2. But you're actually seeing why it's 2. We have to break this 4 into 2 groups, and that gives you your answer. So there you go. We could have done this same problem, though, a different way. What if we did this? There's your 4x plus 2 equals 2x plus 6. What if we did this? Instead of taking away 2, what if we added 2 minus 2's to both sides? Well, what happens in this game? If you put a black one on a yellow one, blue one rather, positive ones on a negative ones, they cancel each other. And what do you end up with? Absolutely nothing at all, and that's what we've got here. So we did that on this side, and then we do it on this side, and it takes 2 of them away. By adding negative 2, it's the same as subtracting 2. Now we've got a new equation, 4x equals 2x plus 4. Now what you do is you take 2 black ones, x's, and you put them on both sides. When they go on this side, the positive x and the minus x will cancel each other. So 2 of these will go, and these 2 will disappear when I put the minus x's on there. So 4x plus negative 2x and 2x plus negative 2x, what do you get? You just have 2x on this side equals 4. Split them up like this, break it into 2 groups of 2. I can see x equals 2. Okay, one more thing. Let's take a look at a question like this. Say you had minus 3x equals minus 6, and you're supposed to figure out what the answer is. Well, you want to find out what x equals. So you need blue things. You need the blue x's, the positive x's. So what we're going to do is we're going to add 3x to both sides, like this. If I add it to this side, these ones will disappear. So we'll end up with 3x on the other side. See how I added 3x to that side? And we're going to add 6 to get rid of the minus 6 from both sides. And you add minus 6 here, that disappears, and the minus 6 goes over on this side. But the key thing is you're doing something to both sides of the equation. You're actually adding 3x's and you're adding 6 to both sides. You're adding 6 and you're adding 3x to both sides. And what do you end up with? 3x's on the right side equals 6. And you just split it up, those 3x's equaling the 6. I can see that x equals 2. And that's your answer. 2 equals x, so x equals 2. And there you go. That's algebra tiles. So maybe you can try it in class. We'll see how it goes.